Okay, so here's a video about 4.6, which is using calculus and calculators to talk about what graphs look like. This is kind of just putting together some stuff that we already learned and also using calculators with it. So conceptually, there's not a whole lot new in this section. We're going to find, we have a function, we're going to find intervals where it's increasing and decreasing. Of course, we already know that increasing is where the first derivative is positive, and decreasing is where the first derivative is negative. We're also going to find intervals where it's concave up and concave down. And of course, we already know concave up means the second derivative is positive. Concave down means the second derivative is negative. And we're going to find inflection points. And for this, we're going to round everything to 2 decimal places. So when you do on the online homework, pay close attention to which ones tell you to round and which ones tell you not to round. This is important. If it's not telling you to round, then if you get an answer like the square root of 2, then you have to put it in just like that. It's the square root of 2. If it tells you to round, then you can write, 1.41, like whatever decimal your calculator tells you. Of course, pay attention to how many decimal places you're supposed to keep. If I'm supposed to keep 2 decimal places, then I'm okay here. But yeah, keep in mind, this and this are not the same thing. This is approximately the square root of 2. If you want the exact square root of 2, you just have to put in the square root of 2. Or else the online homework will mark you wrong. If you're not supposed to round and you put this when the answer is the square root of 2, you'll get marked wrong. Anyway, let me cross this off because this doesn't have anything to do with the problem, really. Right, so all of this is just questions about where the first derivative is positive and negative. That's how I tell increasing versus decreasing. And then where the second derivative is positive versus negative. That's how I tell the difference between concave up versus concave down. So first derivative stuff is this 5x to the 4th plus 20x cubed minus 3x squared minus 36x plus 18. Right? So that's the first derivative. And now what we did before is we made a number line, which we labeled with f prime of x. I would like to label any points on this number line that are critical numbers. Critical numbers are where this is either 0 or undefined. Let me get something out of the way, and this is the thing that is most common for people to forget to check, but is this ever undefined? Well, it's a polynomial, so no. So, okay, so it's never undefined, but where is it 0? Now, this is where normally I would set this equal to 0 and solve for x. This is kind of a complicated thing to try to solve for x. You're going to have a hard time if you set this equal to 0 and try to solve. Luckily, we are told to just use calculators and round our answer for this. So you should have a graphing calculator, but for me, I have